For my agriculture students, yes, in case you have not known, I am also an agriculture tutor. So I tutor a wide range of subjects, right? So biology, chemistry, English, geography, history, agriculture, development studies. Okay, so I'll be putting various videos as time goes on. But today we are looking at soil formation. That's in agriculture. So we will look at soil formation, which really covers how soil is formed. Okay, so we have various uh, processes that contribute to how soil is formed. And the one process that's very, very important here is weathering. So weathering is the process of rocks being worn down into small grains in soil. So that's a big rock being worn down over time, okay, by either the effects of rain or wind. Is it rain or wind? No, that's erosion. Never mind. Weathering, the process of rocks being worn down into small grains and soil. Yes, by the effect of either wind, water, temperature. Okay. Yes, I wasn't so off track then. The thing is, I teach geography, so we have very different definitions in that space. Good. Anyways, we have different forms of weathering. So we have physical soil weathering, we have chemical weathering, and we have biological weathering. And then we also have a composition, which also contributes to soil formation. Okay, so we will examine each of these processes individually. All right, so we start with physical soil weathering. So here it looks at the effect of temperature. So in the red, as you can see, we have heat there. I hope this is very, very. Can you see? I hope one can see, but my picture is not so sharp enough. Um, Perhaps if I adjust my lighting, I do hope I'll be able to. Let us see. Oh well, my options are limited. Yes. Oh, finally. Oh well, we tried. Anyways, physical soil weathering. So with temperature, when it's daytime, as can be seen by my sun, the sun. Okay, so the sun heats up the rock. The rock will expand, as you can see by the red and the heat rays there. And then, so during the day, the rock expands. During the night, the rock contracts. As it contracts, let's say it rains that night, okay, and so the rock will cool down. As it cools down and contracts, it breaks apart. Eventually, over time, it will break apart, and then we have those fragments. Okay, so that's for physical soil weathering. Uh, we're looking at temperature. We're looking at wind. With wind, we have little pebbles, little stones dashing against a bigger rock. And over time, this consistent hitting of the pebbles and smaller rock material with the larger rocks breaks up the larger rock, which results in the fragments, and of course, these fragments form the soil. Same with those fragments, they all form soil. That's the idea here, soil formation. That all these processes contribute to the soil being formed from different fragments and different worn down rocks. Alright? And so we have the effect of falling water. Okay, so I made some errors here, that's why it might look so unorthodox here. But anyways, falling water. So here we have the rock and pebbles that fall with the water. So this is a waterfall. I tried to draw a waterfall, and the water is falling, and as it falls, it has pebbles, and these ones now. Bear in mind, water has a very, very high pressure. Okay, so it's more than just the rocks, it's the pressure of the water as well. Excuse me, that also has an effect on the rocks underneath. So water has very high pressure, which means it could break apart the rock, perhaps gradually. And the pebbles too, they dash against the rock. So over time, this hard rock begins to smoothen. That's why it's rocky and has edges all over. And here it's sort of somewhat smooth. And then here it's broken apart. So over time, weathering happens over time. It's not something that will happen in one day. Oh my gosh, look at the rock. It just broke open today. No. Over time, as years go by, the rocks are worn down, they're broken apart, they form fragments which become soil. That's how weathering occurs. Okay? Now we look at running water. Now with running water, it's not a waterfall, it's just like, let's say, a river, and the current is very strong, and the current carries those little rocks and pebbles which hit and dash against the rock and break apart the rock into fragments. Sort of the similar motion as in the wind, except it's in water, running water. And running water has very high pressure, and so the high pressure, of course, will break apart the rock. And of course, the pebbles will also contribute to that. And as a whole, the rocks are worn down. Now, freezing water, here, um, when a rock has cracks, water will seep into the rock. And eventually, over time, let's say in the night, the water in the rock freezes. As it freezes, it deepens the cracks in the rock. And over time, these cracks in the rock widen, deepen, and then the rock will break apart. So that's my take on physical soil weathering. Alright, now in the next video, we look at chemical weathering. Finally, we'll go to biological and end with the decomposition of dead matter.